Hey everybody, it's Lebo with Lebo's Pinball. This is part 8 of this Bally Star Trek restoration, and we're working on lights, trying to get things kind of straightened out now. If you watched last time, that's basically where we left off, and you see all this flicker here. We're going to see we can deal with that. But not only just as there flicker, we also have some lights that just are not lighting up. In fact, if I go into the test mode here real quick, just press this button just one time, it should just be cycling them all on. You'll see, like, that one's not coming on. It could just be a wiggle of the bulb, or it could be a socket. But I got basically all of these down here that are acting up. This one kind of blinks a little bit, so got to tear into it, see what's up with that. The first thing I'm going to do, I know I need to go ahead and put in the new board, the new light driver board, and it should handle the flicker. So we're going to go ahead and throw that in there. At least we can kind of rule things out with that. If we still have issues, we'll just keep diving in deeper. All right, this is the lamp driver board that is over here. Actually says so there in the bottom right-hand corner. It'll also say A5. If you're looking in at schematics, it'll refer to that as A5, and all the connectors will say A5, and then J2. Like for example, that's J2 right there for the connector in the header. Number 2, and that's 4. You got 1 and 3. But anyways, we're gonna go ahead and unplug all these. We'll pop this board off. This board is basically held in these little snap-in little standoffs. I think there's one screw sitting up here, but we're gonna get this out and we'll throw in the other board. The board is installed. We got all the connectors in. And one thing I want to mention, so this board, as well as some of the other aftermarket things where they put in the little resistor daughter cards that kind of go in between these connectors. There's an additional connector here. This is actually J5. It's a 5th one that's added, and what this is supposed to do, you got to tie this somewhere, ideally up in like this board here, where you're getting the positive 6 volts, I guess is what it is. Yeah, this wire, by the way, this is not a ground wire. This is actually providing the constant voltage, and then all the lights are basically turned on by grounding them. But anyways, what you got to do, I've just sort of temporarily hooked up a wire. I just sort of put a little alligator clip onto this braided wire here, and just tied it to the end of the wire that goes to that, just so we can test it out. So, all right, so this is kind of moment of truth. Let's flip it on and see what we got. All right, well, the flicker is reduced significantly. I mean, I would say 99% gone. And in the video, it may not be coming across at all. I really don't, I mean, just barely. Like if I see this partially, I could kind of see a tiny bit. But folks, this actually looks really good. Now, the other thing I want to mention is, look, you got lights that are working here in areas that they were not working before. I remember that one was out. Let's actually hit the little test button here and test all these lights. It's a lot easier to look at. So what do we got? This number 2 is still out, so we got to figure out what's going on with that. And that's weird. It looks like it just went out in the video, but it was probably harmonics with the, or a phase or something with the way that it's actually flashing, because I'm looking at it, and like right now, those are blinking completely solid. There's not an issue. But yeah, looking all through here, there's just like a couple that I'm going to have to kind of trace down. And it could be that, these connectors are not the world's best. We may end up repinning, just putting a whole new housing for the connector, new pins. And, it's a little bit of work to go do all that, but it'll make it even more solid. This game was already doing pretty well on connectors. But, that just improves it a little bit more. So, anyways, just kind of keep moving along, see what else we can do. Well, I seem to have been coming down a little bit with a illness here, and I've been losing my voice, but while I still got just a little bit left, go ahead and mention what I've been working on here. So, I'm definitely going to want to rebuild these connectors. These housings, or I'm sorry, the pins that are in there are just, they're known to not hold up real well. I've been wiggling them around and getting all the lights to all work. Like this number 2, that if I kind of wiggle some of the wires here a little bit, see, look, now it's on. I'll take my finger off and it's off. And get some of them that just want to totally go out. But I'm going to basically need to go through and figure out how many pins are on each one of these and get them ordered. And then that's going to be a little bit of a job to go redo them all. So in the meantime, while I'm waiting on that, we're going to go ahead and one thing I really want to do, even though it's working right now, this rectifier board is looking pretty sad. And I've got stuff to basically rebuild a whole brand new one, along with connectors. Once again, we're going to make this game as solid as practically that I can. So sorry for the voice fading out, but I'm going to keep moving ahead. All right, so I went ahead and kept filming and came back now to go ahead and give a voiceover. So I wanted to show out here, these are the connectors that need to be rebuilt for this rectifier board. They just, they take a lot of beating, just all the power input and everything going in here, and they just kind of get fried up. Now, these are not too terrible, but I've got new connectors here that I want to go ahead and use. And I've got 2 sets of pins. You got some for 18 to 20 gauge, and then the others for 22 to 26 gauge. And that's what you've basically got. I think it's 18 and 20 gauge. It could be 22 gauge wire on here. But this first wire I want to show, this one's an 18 gauge. And the way I do this is I will always start on one end, just do one wire at a time. You'll see the one tool that I use here for stripping the wire. This is one of my more favorite ones to use, but it really only goes down to about an 18 or maybe a 20 gauge wire at best. But stripping that end off, you're going to go ahead and get the new Trifurcon pin, and here you can see this one tool that I have where it will ratchet and hold that pin in place, so that I, with just one hand, I can just kind of carefully hold the tool. The other hand, just slide it in, and you want to get just enough to where you've got the insulation that is getting crimped by one little section of the pin and the conductor on the other section. I think I show that here. Yeah, when I zoom in, you can see there's 2 sections that get crimped. You got the insulation side and then the part that's where the actual conductor is. And so now once you have that, you can then get your connector and go ahead and start the process. And there's a little locking tab here that lines up with the slot. And here you go, you can see it locking in. Once you do this, then you can just verify that it's not coming loose. You're going to then go to the next wire and then just proceed forward, and just do them one at a time. That way you don't ever get, pins going into the wrong socket. Now, what I'm wanting to show here, I've actually jumped ahead just a couple wires, but what's different about this one? So this one's going to be a 22 gauge wire, and this is a different set of strippers that I've used. They're pretty basic, but man, they work really well. And I think they're pretty sharp. So, I just wanted to show a variety of different ways of what you're going to run into anytime that you're repinning connectors on games. I mean, it's pretty typical that you're going to have, a lighter gauge, 22 or maybe 24 gauge wire, and a little heavier, closer to the 18 gauge. But it's the same basic process. And once again, here I've got that same ratcheting tool that does the crimping, but I just have to kind of check it up into a different spot here that holds it a little bit better. All right, so now I've got all the connectors rebuilt here on this rectifier board, and I went ahead and plugged them all back in just to kind of test to make sure that the work that I did there is working right. So now I'm going to go ahead and flip the power on. I got the lights that all came on fine. The game boots up right. So now let's go ahead and just take these connectors right back out, because now it's time to move over into pulling off the rectifier board. So here I've got the cage around the transformer. That's going to come out. I'm going to throw some new paint on it to clean it up. But next you got to get this whole assembly out. There's some some screws that are here on the side. You can see a couple screw holes on the left, and then you've got 1, 2, 3. I think there's 3 screws, wood screws, that go on the right. Once you take those out, that whole assembly needs to come out. All right, so here you've got the actual rectifier board, and you can see where it's kind of looking rough, where some work's been done on it before. Just again, I wanted to work on it and put in this new one that's here, just to err on the side of reliability. The other one was working, but I don't think it's going to hold up well. Now, to be able to swap this out, though, you've got it wired in. The backside of that board is soldered in to the transformer. So you got to take some screws out here that are tying the bridge rectifiers on the back of the old board to the metal. You can see them right there. But here you can see all the wires from the transformer that are all soldered in. So that's the thing you got to do, is you got to unsolder them. There's 12 different connection points, but a total of 14 wires. So a couple of them, they're doubled up wires. That's why you've got 14 instead of 12. So it's just basically, if you lay it out like this, you can just kind of methodically go through them one at a time, so that you don't mix up wires and get them in the wrong spot. But it's relatively straightforward. You just have to kind of be careful about what you're doing, and just do a quality job and not get things goofed up. So here we go. We're just soldering it in place. It's just, like I said, it's just kind of a tedious process to go through it, but here we have it. We've got it all done. It's all the wires have been transferred over, and it's just a matter of putting it back into the whole assembly. And the assembly is all together. Even repainted the little cage around it, and it all's put back in place. Time for the MPU. So here's the MPU board that's off of the Star Trek, and what we're going to do to it, really the only thing that we're going to do so far, I'm not planning on changing any of the headers or anything, because I don't have a problem with them, but this battery, it's actually, there's 3 cells that are in here. They're in series, obviously. They're rechargeable, but even this can go bad over time. And so, sorry about the focus there. Look at that. I think it may have been replaced at one point, because that solder looks like somebody's been in there and didn't really clean up the flux. But whatever, we're gonna take this off, and in place of it, I've got one of the Frank's battery board. So if you ever watch TNT, Todd Tuckey, and Frank there, he makes these little battery boards. So what this has on it, it's real simple. I mean, you've got a little battery holder where you can put in just a standard 2032 battery. But there's also a little blocking diode. Since that's not a rechargeable battery, you don't want to be sending power back to this to charge it back up, because that's not going to work. So this diode prevents that from happening. It just keeps it from flowing back. So it's only going to flow out of the battery one way. And you can see there's negative sign on there and a positive sign right here on the end. And basically the idea with this is that we're going to take out the rechargeable battery, clean that mess up there, clean the holes out, drop this thing in, solder it in place, and then we'll be good to go. But the positive is basically on this side, and the negative goes on this side. There we have it. The battery board has been installed. I dropped the battery in. I went ahead and tested the continuity here, and I know that everything is working good. Even kind of cleaned up some of the mess that was here on the back when we soldered the new ones in. So let's go drop it back in. All right, so the MPU is back installed with our fancy new Frank's battery board. So now let's turn it on, make sure everything's working good. I like to test everything one at a time every time that I do something electrical. That way I can track down if there's an issue. Did I just cause the issue, or is it, if it's multiple things that change at once, it's a little harder to do. Now, you're seeing this blink that's coming through here in the video. It's not doing that again in real life. So, all right, let's, of course it says it's got 0 credits, 0 balls. Now, one thing that's kind of cool, this, the game start button, the credit switch that was on the CoinMax has been moved up here. So if you press the button just enough, or enough to close that other switch. That just added a credit. So now, if I press it again, lightly, it just took a credit away, and it, it started the first game. Now, if I press it a little harder, of course, it's trying to start add the second player, but I don't have any credits. But press a little harder, I got another credit. Press again, there we go. So see now. Anyways, just figured I'd point that out. I don't know if I mentioned that earlier, but okay. So let's go ahead. Now there's no ball in here, but we'll pretend like the ball is in play. All right, 300 points. Okay, it should have added, actually not 300, but it would have been whatever the hyperspace was, which was just lit up as 2,000 just a second ago. And then once I hit that, it added 2,000 more to the score. So now we're at 2,300. And then it also advanced this to the 4,000. And again, I mentioned this earlier, it keeps fading in and out only in the video. Real life, it is not doing that. It just has to be something like the frame rate of the video and what's going on with the actual game. It's just happened to be lining up in phase. So anyways, okay, we're good here. I think what we're going to do next, again, we're just kind of doing some board maintenance here. I don't like to use the term bulletproofing because, we're not bulletproofing everything here, but we're trying to address some of the known areas that typically can go wrong, at least just some of them. So we just addressed that battery, and now what we're going to do is we're going to spend a little time here on this whole solenoid driver board. I'm going to replace some of these capacitors here. That's the main thing. And after that, we're going to move down to the soundboard, and we got some things we'll do to it too. Again, it's working right now, so you might be thinking, why are you going to do this when it's working? And that's a good point. If it ain't broke, don't fix it. But again, these are things that are known to be issues, and I'd like to go ahead and address it now while we've got it before the game goes on to the new owner. All right, I tell you what, folks, let's wrap it up for now. We've been really busy trying to get through a lot of stuff here, and we are definitely on the final stretch. Really, all we got left is, like what I was mentioning there in the solenoid driver board. I got to swap out caps there. I'm going to rebuild the caps that are on the soundboard, and finally, I've got some more of those connectors. They just showed up, and we're going to finish out replacing a lot of connectors on the other boards and get this thing wrapped up and standing tall. So thanks for watching, and we will see you guys next time.